Today we are going to discuss about beam strength of spur-gear teeth or Lewis equation. To understand beam strength of spur-gear tooth, consider each tooth as a cantilever beam loaded by a normal load Fn. This normal load Fn is resolved into two components as a radial force and tangential force. This radial force component induces direct compressive stress of relatively small amount and hence its effect is neglected. Next we have a tangential force. This component induces bending stress which tends to break the tooth. Hence, beam strength of gear tooth is defined as the maximum tangential load the gear tooth can take without failure. To determine the beam strength, we use Lewis equation. So, I hope you understood about what is beam strength and Lewis equation. To derive Lewis equation, we have the following assumptions to be made. The effect of radial component Fr is to be neglected since the compressive stress produced by it is very small. Next we have a tangential component Ft. We should assume that it is uniformly distributed over the entire face width of the gear. The next assumption is the effect of stress concentration is totally neglected. And fourth assumption is at a time only one pair of teeth is in contact and full load is acting at the tip of the single tooth. These are the four assumptions which we should consider while deriving the Lewis equation. To start with Lewis equation, let us consider a single gear tooth and which is subjected to the normal force Fn and which is resolved into two components as radial force and tangential force. This tooth has a thickness of T which is shown at the base and it has a height of H, and we already know that each tooth has to be considered as a cantilever beam. When I say cantilever beam, one end of the tooth has to be fixed and other end has to be free. So if we rotate this figure as a cantilever beam, so this figure can be drawn like this, where you can see that the root of the tooth is considered as a fixed end and the tip of the tooth is considered as a free end, and hence this normal force is resolved as a radial force and tangential force. Now we can see that the thickness of the tooth is nothing but the depth of the tooth and height of the tooth is nothing but the length of the tooth. So this is the way to be represented when we consider tooth as a cantilever beam. Because of the tangential load, the maximum bending stress induced is at the root of the tooth, and hence let us take the bending moment at section XX as M is the bending moment, M is equal to Ft into H, that is force into the distance. So this can be taken as Newton millimeter, and we know that height of the tooth in terms of millimeters, the face width of the tooth in terms of millimeters, thickness of the tooth along the section XX, again that is in terms of millimeters, and next we have moment of inertia of tooth section about the neutral axis, that is moment of inertia of tooth at section XX about the neutral axis and it will be in terms of mm raised to 4. Because of this tangential load, the maximum bending stress at section XX is given by m is equal to ft into h. Okay, we'll see next for the bending stress equation. The maximum value of bending stress at section XX is given by sigma is equal to m by I into y, where m is the bending moment at section XX. We already know that m is equal to ft into h, where y is the distance from the neutral axis. For a rectangular section, we know that it is depth divided by 2, and here the depth is nothing but the thickness of the tooth, so it is t by 2. For a rectangular cross section, the moment of inertia is given by bd cube by 12, and here the depth is thickness, so it is bt cube by 12, where b is nothing but face width of the tooth. Now substituting the value of m, the value of I, and the value of y in the bending stress equation, we have sigma is equal to ft into h into t by 2 divided by bt cube by 12. On further simplification of this equation, we can write ft into h divided by bt square into 6, can write. Therefore, for tangential force, this equation can be rewritten as ft is equal to sigma into, bringing this denominator on this side and further simplifying, sigma into b into t square by 6h. In the above equation, the parameter t square by 6h is this value, t and h value will be mainly depend on the circular pitch, and here we can take this t is equal to x into circular pitch, where x is the constant, and h is equal to k into circular pitch, where again k is the constant. That is nothing but x and k are the constants, and substituting value of t as x into p and substituting value of h as k into p in the above equation, we can write ft is equal to b into sigma into x square p square divided by 6 k into p. On further simplification, we can write ft is equal to b into sigma into P into x square divided by 6k, that is cancelling one of the p here and we are bringing the circular pitch outside. Further, this equation can be written as T is equal to B into sigma into P into y. That is nothing but the term which is there in the bracket x square by 6k is replaced with the letter y. This y is known as Lewis form factor or tooth form factor. We know that the circular pitch P can be written as pi into m in terms of the module, since module is the one of the important factor for the gear tooth profile dimensions. Further, this equation can be written as Ft is equal to B into sigma into pi into m into y. This equation is known as Lewis equation. Thank you.